All right, guys, good morning. Hope you guys had a lovely weekend. Um, we're going to be doing more circles. Today we're going to be talking about circles in standard form. All right, so on Friday, we did circles in center radius form. And center radius form, that was a very nice form, but they don't always have to give you circles in that form. And today we'll take a look at how we could get from standard form into center radius form. So if you forgot on Friday, this is what we looked at, right? We looked at equations of circles in center radius form. Here's our general equation. And again, this is a very nice form because you can find the center, h comma k, and the radius very, very quickly and very easily in this form. So what if they do not give it to us in this form? What could we do to make it look like center radius form? So let's take a look at our first example here. And also, by the way, as you probably noticed, there was no PDF notes. So we're just doing a blank notability today. There really wasn't any reason to give you a template of the notes because we only have 4 equations we're going to be looking at today. So for this first one, the question is find the center and radius of a circle with this equation. All right, so there's our equation, find the center and the radius. So as you can probably tell, first of all, that does not look like center radius form. So the question is, how can we make this look like that so we could find the center and the radius? So in this example, well, if we group these first 3 terms, think about what we could do to make it look like x minus h squared. If we're saying to factor, that's it. Because, oh, also I noticed I made a mistake here. Sorry, this should be y squared minus 4y, not x. My bad. Right. So anyway, back to this. If we look at those first 3 terms, what multiplies to 1 and what adds to 2, the answer will be 1 and 1. So doesn't this factor to x plus 1 times x plus 1? And what is x plus 1 times x plus 1? Well, that is x plus 1 squared. So we are already well on our way to having it look like center radius form. Now all we have to do is do the same thing to the y terms, right? Can't we group these 3 y terms? And luckily, actually very luckily, this also factors so that it is y minus 2 times y minus 2. Right, so that factors to y minus 2 squared, right? Because negative 2 times negative 2 is positive 4. And of course, negative 2 plus negative 2 is negative 4. Right, so make sure you factor with the right signs. That will factor to y minus 2 squared. And all of that is equal to 36. This is equal to 36. Right, so all we did is we factored to go from there to there. And now we have our equation in center radius form. So our center here is negative 1 comma positive 2. Right, make sure you're careful with that. It's not 1 comma negative 2. Right, our center is negative 1 comma positive 2. Right, the signs are opposite. And again, that just comes from our general form for center radius, right? We saw in the equation, it was x minus h. So if it's x plus 1, right, that x value has to be negative 1, the x coordinate of the center. And of course, our radius, again, you gotta be a little careful. Our radius is not 36, but the square root of 36, it's 6. Right, and you could graph standard form equations in your calculator, but I don't really recommend it because you gotta do a little manipulation, usually at least. But let me share that with you and we can take a look at how to do this on the calculator. All right, so on the calculator, go to the graphing page, right? And normally when we graph functions, but a circle is not a function, so we gotta go to menu, choice 3. We gotta go to a special equation template. And of course, that is of a circle. So on Friday, right, we did center form. I call it center radius form, but it's right there. But there's also standard form, which looks like this, right, with everything multiplied out and expanded. So if you click that, well, all the terms are in different orders, but we still got our x squared, we still got a y squared, our x and y, and then we got a constant. So when you type in a 1 here, notice how it auto-populates the 1 in front of the y squared as well. So that's going to be like part of the definition of a circle. The x squared and y squared will always have the same coefficient. So if you type in a 2, notice how that pops up as a 2. If you type in a 27 or 47, that pops up as a 47. Right, those two coefficients in front of the x squared and y squared need to be the same in order for it to be a circle. Right? You can imagine if they're different, well then we're kind of like stretching it out more in one axis than other. If we have like 3x squared plus 1y squared, that would actually make it the equation of an ellipse, right? Which is like our oval shape. So if I put a 1 here, we got 1x squared and 1y squared. We got 2 x's, so there's going to be a 2 there. We got negative 4 y's, so just put a negative 4. And lastly, we have this constant. So if you look back to our equation, we have x squared plus 2x plus 1. We also have a plus 4, and that's equal to 36. So if we do 1 plus 4, that's 5, right? And it was equal to 36, so we still need to subtract 36 from both sides. So 5 minus 36, that's going to be negative 31. All right, so that is how you would type it into your calculator. So hopefully when we do this, we are seeing a center at negative 1 comma positive 2. And that looks good. Our center is right there. If you want to check, you can go to geometry, points and lines, and you can type in a point by coordinates. So I can type in negative 1 comma positive 2. And there is our center, negative 1 comma 2. Right, our radius is 6, so if I add 6 onto this x coordinate here, I should have the 0.5 comma 2. I'm also going to check that real quick. Geometry, points and lines, point on, and, sorry, not point on, menu, geometry, points and lines, point by coordinates, 5, hit enter, 2, hit enter, right, and you can see that does indeed mean our radius is 6. We can also just draw in a radius if we do segment, right? And you can measure the length of that radius anywhere you want. So whichever radius you drew in, measurement, length, and 6 units. All right. So we're not going to be really doing too much. I just wanted to show you how you could graph it if you wanted to. But let's go back to our notes now and finish this up. All right. So that is that. And let's take a look at example number 2 here. All right, so example number 2, I'm going to make this one x squared minus 6x plus y squared plus 8y equals negative 9. And if you compare with the first one, you might notice, well, this first one, I kind of gave it to you, right? I already gave you x squared plus 2x plus 1, which just factors to that. If we try the same thing here, right, we get x squared minus 6x. And how the heck do we factor that? Well, that factors to x times x minus 6. But that doesn't really work for us because that is not center radius form. So we have to do something else here. So the reason it works so nicely in the first one is, actually we'll take some notes up here. The reason it works so nicely in the first one was because this x squared plus 2x plus 1, that is something we call a perfect square trinomial. Right? We should know what perfect squares are already, right? Perfect squares are things or numbers like 4, 9, 16, right? Because that's 2 times 2, 3 times 3, right? Or 4 squared, right? All these can be drawn as a square, right? This would be a 2 by 2 square, 2 squared, 4 is a perfect square. So in this case, x squared plus 2x plus 1, that entire trinomial is a perfect square because we can write x squared plus 2x plus 1 as a square with lengths of x plus 1 and x plus 1. So that was very lucky, because that automatically gave us what we needed for center radius form, which was x plus 1 squared. Right? And then same thing for our y terms. This was also a perfect square trinomial. And wouldn't that be nice if this here were a perfect square trinomial? So right now it's obviously not. So what could we do to make it a perfect square trinomial? Right? So think back to Algebra 1. There is a very fundamental skill that you learned in Algebra 1 that we could use here to make this a perfect square trinomial, and therefore get it into center radius form. All right, I'm hoping some of you are thinking about it. Right? I actually do want you to think about what we could do. And over here, I just gave you a hint by leaving little spaces where we're going to be needing to add something. So hopefully you thought of completing the square. Right? If we complete the square, we can make it a perfect square trinomial. So I'm just going to tell you what number we add here, right? The number I'm going to add here is, does anyone know? All right, very good. We're going to be adding a 9 here. So how do we get this 9? Well, you might remember the trick that we add half of this middle value, which is the -6. All right, so we're going to take -6, we're going to divide it by 2, and then we square it to get this number that we add to complete the square. So if I just write this out for the very first one, -6 over 2 is -3, right? And -3 squared is 9. So the rule in general is, in order to complete the square, we add b divided by 2 squared, right? And I'm sure some of you remember that, and I hope you guys know where that comes from. Right? You probably don't, because I don't think they show you, but I'm hoping that they did show you last year. If you took Algebra 1 at the high school, I'm hoping your teacher showed it to you. But over here, right, we're going to be adding 8 over 2, which is 4, right? So 8 over 2, which is 4, and then we square it. That's going to give us 16. All right, so if you don't know where this comes from, don't worry. I do want to talk about where that does come from in an honors class. So we're going to add a 9, and we're going to add a 16 to make these perfect square trinomials. But of course, we cannot just add these numbers to one side of the equation. We can't just add a 9 and a 16 to the left side, right? If we add 9 and 16 to the left side, we need to add 9 and 16 to the right side. So I also need to add a 9 here, and also a plus 16. So overall, I added 25 to the left, so I add 25 to the right. And now let's take a look. X squared minus 6x plus 9, doesn't that factor to x minus 3 times x minus 3? Right, we made a perfect square trinomial, so that's x minus 3 squared. Right, for the y's, that will be y plus 4 times y plus 4. Right, and by the way, a little trick, if you ever have difficulty factoring these for whatever reason, it's always going to be this number here. The number you get after you divide by 2, right? That b divided by 2 number is always going to be that part of the factors. We can see that here as well, right? 8 divided by 2, that gives us the 4. Right, so that will be y plus 4 squared equals to our radius squared, which is -9 plus 9 plus 16, which is 16. And so that's equal to 16. Right, so the original question should have really been find the center and radius of that circle. So again, careful with the center. Our center is 3, -4. Also a little careful with the radius. The radius is not 16. There's always someone that forgets to take the square root. Right, the radius squared is 16, so our radius is 4. All right, so that is how we go from standard form to center radius form to find the center and the radius. Okay, so what I do want to do is talk about how completing the square works. So I think this is a very nice geometric approach to showing why completing the square works. I don't know why I wrote "duh" in front. So "duh" completing the square. So completing the square. So I'm going to be starting with a square, and I'm going to add this little extension to make it a rectangle. All right, so here's our square. Here's our extension to make it a rectangle. And I'm going to make the square x by x. And this little extension I added, I'll make that a length of b. All right, so if I ask you to find the area of this rectangle, well, that would be x times x plus b. Right? In other words, right now we have x squared plus bx. Right? So in general, this is what we want to complete the square on to make it a perfect square trinomial. Right? We want to do x squared plus bx and then add a number. And once we add that number, we want it to factor to something squared. Right? So that's our goal. So what I'm going to do in this diagram is I'm going to cut this rectangular portion, right, that b by x rectangle. I'm going to cut that in half. And I'm going to take this area over here, cut that piece off, and I will attach it to the bottom of the square here. So what that is going to look like is something like this. There's our square again. I cut this piece in half, and I put the other half of the piece down there. So this square is still x by x, but what is the dimension of this side of the rectangle now? Well, we cut this length of b in half, so wouldn't this be a length of b over 2? And over here, this will also be b over 2. So again, we want to complete the square, right? Once it's a square, the area is going to be side times side, and that's going to be the same factors because it's a square, so that's going to make it a perfect square trinomial. So don't we need to add this little bit of area right here? And what is that area that we're going to need to add to make this a square? Well, aren't the dimensions b over 2 by b over 2? So to complete the square, we add that area, which is b over 2 times b over 2, or b over 2 squared. And isn't that beautiful? So what's the area of this square now? Well, it has the same area as before, x squared plus bx, right? Because all we did is we cut this off and moved it to the bottom, so that's still the same area overall. But now we added this extra piece, b over 2 squared. So the entire area is x squared plus bx plus b divided by 2 squared. And what do we get when we factor this? Well, the area of the square is side times side, or x plus b over 2, right? That's the length of one side, squared. So whenever we add b over 2 squared, we complete the square by adding this quantity. And it would always factor to something squared because it's a square now, right? It's a perfect square trinomial. So that's kind of the idea behind completing the square, and I think that's really nice. It's a really nice way of seeing it. So hopefully, if you've never seen something like this before and you didn't know where completing the square comes from or why you add that quantity, right, this is a nice visual way of seeing where that b over 2 squared comes from. All right, so what we're going to be doing is just a couple more examples. Which one did we just do? All right, so we're going to be doing 2 more examples, so write these down. Number 3 here. Let's find the center and radius of this equation in standard form. So technically, it's not really in standard form, right? In standard form, as you can see in your calculator, it's when it's equal to 0. So you might see that, but the equation I'm giving you is this equals 4. All right. So what is our center and what is our radius? So first thing I'm going to do is I'm going to be grouping the x terms together. So I have x squared plus 3x, and then I'm going to leave a space, plus y squared equals 4. And let's think, what do I need to add onto here to make this a perfect square trinomial? Well, this one is going to be a little trickier. So remember, we had b over 2 squared. So our b value here is 3. So what I'm adding here is 3 divided by 2 squared. So what's 3 over 2 times 3 over 2? Well, that is 9 over 4. If I add 9 over 4 to the left side, I'll also be adding 9 over 4 to the right side. Right, and what do I need to add to this y squared to make it a perfect square? Well, it already is a perfect square, right? I don't need to add anything to y squared because y times y, that is already y squared. So I don't need to do anything to that y squared to complete the square. And let's keep going. Now that I have this, right, how does that factor? So what multiplies to 9/4 and adds to 3? That's a slightly difficult question, right? But remember, we can do the trick. When we saw completing the square, we saw always factors to x plus b over 2 squared, right? I also told you when we factor, it's just half the b value here, right? Which is b over 2, right? Which is, of course, the same thing that this is saying. It's just b over 2 over there. So if you think about it, our b value again is 3, right? 3 over 2 is just 3/2. That is how it's going to factor, right? X plus 3 over 2 times x plus 3 over 2. All right, we can think 3 over 2 times 3 over 2 is 9 over 4. And then 3/2 plus 3/2, isn't that just 3? So once we complete the square, this factors to x plus 3 over 2 squared plus y squared equals to, what's 4 plus 9/4? So always write this as a single fraction. Try not to write this as a decimal, guys, or a mixed number. It takes an extra 10 seconds to do it. So to combine these fractions, get a common denominator, right? 16/4 plus 9/4, that is 25/4. So what is our center and radius now? Well, it's at h comma k, right? So let's think of this as x minus h squared. So our h value is negative 3 over 2. And what's our y value for our center? So remember, this is plus y minus k squared. Well, what's the k value if it's just y squared? Isn't our k value, you can think of it as y minus 0 squared, right? So our center here will be negative 3/2 comma 0. And our radius, well, the reason I want you to write as a fraction is, what's the square root of 25 over 4, right? R squared is 25 over 4, so r is the square root of that. Well, if I square root 25 over 4, that's just the square root of 25 over the square root of 4, which is 5/2. All right. Yeah, I guess I'll keep that. And let me just write this a little nicer. So there's our center, and there's our radius. And again, I recommend just practice typing that into your calculator. You can check to see if that's the center and to see if you have a radius of 2.5. All right, so we're going to do one last example here. I recommend you guys pausing the video and trying this on your own first. And here it is, x squared plus y squared plus 4x minus y squared minus 8 equals 0. Wait, sorry, that's an extra y squared. That should not be y squared, that should just be minus y. All right, so hold on, let me just arrange this. All right, so now go ahead and pause the video if you want to try this. The question is, again, find the center and radius of the equation of this circle. All right, so let's take a look. First of all, I know this is a circle because the coefficients in front of the x squared and y squared are both the same, right? They're both 1. So also notice everything's out of order, right? X squared and 4x. So I'm going to put those guys together first. I'm going to write this as x squared plus 4x. I'm going to leave a space to complete the square. I'm going to put my y terms together, y squared minus y. I'll leave a space. And this minus 8, that minus 8 is not what I need to complete the square. So just to avoid confusing ourselves with that minus 8, I'm going to add 8 to the other side and leave it like this, right? So my first step is kind of just setting myself up to complete the square and to avoid mistakes by moving that 8 over, right? Technically, we could leave the minus 8 over here and then still complete the square, right? And then move the 8 over later, but just move it over now because I think it makes it a lot easier. So to complete the square over here, what number do we add? All right, we're going to be adding 4. Everyone good with that, right? Half of 4 is 2, and 2 squared is 4. All right, what number will we be adding here? A little trickier, but also not too bad. We're going to be adding 1/4, right? So take half the b value, right? Our coefficient of y here is 1 or -1. So what we're adding is -1 divided by 2. We square a half, right? Squaring a half is a 4th. And by the way, the number you're adding is always, always, always going to be positive, right? Because whenever you square a number, whether positive or negative, it's going to be positive. So I added a 1/4 here, and I added a 4 and a 4th. So make sure to add 4 and also a 4th to the other side of the equation as well. All right, now when I factor this, this factors to x plus 2 times x plus 2, or x plus 2 squared. I lost my plus here. This side factors to y. Well, again, if you're confused about how to factor this, remember it's going to factor to b over 2, right? Y plus b over 2 times y plus b over 2. So that's going to be y. And then plus b over 2, that would be plus -1/2 or -1/2. Right? And let's think about it. -1/2 squared, right? That's a 1/4, right? And -1/2 times 2, or -1/2 plus -1/2 is -1. So that's how that factors, and this is equal to, again, write this as a single fraction. So that's 12 1/4. I can write 12 as 48/4. Sorry, plus a 1/4, and so that's 49/4. And now we're done. Our center is -2, +1/2, and our radius is the square root of 49/4, which is 7/2. And that's it. All right. I could ask you to sketch this out. I could ask you to find 3 other points on the circle. I could ask you to find 5 other points on the circle. Right. We actually have a nice center. So from the center, you can just add 7/2 and subtract 7/2 from the x values, right, to get those 2 points on the left and right side. You can go up and down also, right, by adding or subtracting from the y value. That's 7/2 to get some points. So yeah, so that's going to be it for today. So I didn't want to give you spoilers in the title, but the real title of this should have been Circles in Standard Form. Actually, never mind. I was going to add like by completing the square, but that doesn't make sense. It should really say getting circles in standard form into center radius form by completing the square. So if you have any questions, let me know. If you need to freshen up with completing the square, let me know. I can send you some links to practice completing the square. But I think that's going to be it for today. Yeah, so take care, guys, and I'll see you guys on Wednesday.